Hello students, I am Dr. Saliha Jamal, Associate Professor in Department of Geography, Aligarh Muslim University. So students, we are discussing, if you remember, the functions of different tools of spatial analysis with the case studies. In previous classes, we have discussed about the buffer works in spatial analysis, and then we have discussed the interpolation in spatial analysis. Today's class will focus on how the overlay works in spatial analysis, and examples will be given with some of the case studies. If you remember, we have discussed the applications of buffer, we have discussed the applications of interpolation, and now we are going to discuss the applications of overlay. But the difference is that today we are going to discuss is with some of the case studies to make you to develop more clear understanding about these tools in spatial analysis. Before discussing the case studies, I would like to discuss what overlay analysis is. When we talk about the overlay analysis, as the term is signifying, overlay means we have to superimpose one upon the other. We have to give the input layer to the software environment, even we can call it most importantly, that is the GIS environment, the input layer, different input layers one upon the other. So the important attributes can be integrated for a certain task. So overall it can be said that overlay analysis is a group of methodologies which is generally applied for some operations in order to find out optimal site location, or we can say for suitability modeling, which is the suitable place. For example, if in urban planning some road construction has to be planned, then before the road construction, the certain data is required. The data may be in the terms of topographical layer of that place, the data may be in terms of the slope, the data may be in terms of the existing road networks, the data may be in terms of the vacant places, the data may be in terms of the population. So we can overlay all these factors, all this data in order to get the integrated output, so that the major road networks which has to be planned, that should get a proper route, so that no traffic congestion should take place at particular points, etc. This is what we can say the overlay analysis with the certain methodologies, actual optimal site location, or we can say suitability modeling can be done. So it is one of the technique of spatial analysis, we can say, by applying which to a common scale of values to diverse and dissimilar inputs in order to create the integrated analysis. We generally acquire data from different sources that may be at different scale. So actually we apply a common scale of values to n number of different dissimilar inputs, the inputs we are giving. Because when I say some data may be in terms of the counts, some data may be in terms of, we can say, relief aspect, some data may be in terms of the network, then we can say we have to apply these dissimilar input to a common scale in order to have the integrated analysis. So actually the overlay analysis, we can say overall, if you see here, it is a process of combining data or information from multiple data sets. For example, here you can see there are multiple data sets we are having. If you see, we are having the base map, we are having the imagery, we are having the land cover, we are having another input layer of demographics, we have another layer of wetlands, we can say another layer of topography, then we can say another layer of zoning and parcel. Means we are overlaying this different layer, as we saw in previous slides. Means here what we have done, we have combined data and information from multiple data sets. So these what you have seen here, these are the multiple data sets which we are going to consider for the integration in order to get some new information, some new data on the basis of set criteria, whatever our study is or whatever our set criteria is. So accordingly, we take different factors and we overlay certain layers one upon the other. If we take another example, students, here you can find the real world, then you can have the land usages, what types of land usages, maybe somewhere there is the residential area, somewhere maybe the we can say commercial area, industrial area, etc. So actually the land usages. Then we can have the elevation input layer, the input layer in terms of the elevation, what are the counts, we can say the elevation. Then we have the parcels of land, another input layer. Then we can have the input layer for the streets, if you see here. Then finally we can have the input layer of customers, accordingly how the customers are distributed. So for a particular purpose, on the basis of set criteria, these input layers from the different this we can say overall different data sets can be combined in order to get the information according to the need, and we can say according to the set criteria. Actually, what are needed, what if in fact we can say what needs for the analysis. If we see, overlay analysis often requires analysis of many different factors. What are the different factors? Because we are taking different data sets, we acquire these data sets maybe this from the same source or from the different source, means multi-layer, combining multi-layer, we are combining multi-layers. So here those multi-layers are individual factors. So first requirement is that overlay analysis requires many different factors. For example, if the set criteria is, we can say what I have given the previous example, that we want to develop certain transportation network in an urban area so that traffic jam or congestion on the street should be avoided, means our set criteria is this. Accordingly, we can take many different factors. That different factors may be in terms of you can have the existing road layer, whatever, the demography of that place, we can say the elevation of that place, or we can say the whatever the existing road network are present in that place. So these are, we can say, different factors that is to be considered, that is to be combined, etc. So first need of the overlay analysis is, we can say, we need many factors, many different factors to be considered in terms of the input layer. Now if you see the second need, here you can see for instance the example is given here. For instance, choosing the site for the new housing development. If we want to choose a site for the new housing development, we can consider the factors like cost of the land, one of the very important factor we can say, the cost of the land, and another we can say the proximity to the existing services, because whenever we choose a particular place for new housing development, we consider certain things like what will be the accessibility to certain services, amenities and facilities, what are the slope of that particular place, is the particular place is prone to flood or not. So this type of factors will be considered. So here we can give the example for developing new for developing new housing, we can take such factors like land cost, proximity to existing services, slope and flood frequency. These factors may vary from person to person. What is the more which factor is to be given more priority, that depends upon the that depends upon the perception of the different person. For example, I may consider the cost of the land is the first priority for me, or you may consider no, proximity to the existing services, that should be considered priority for you. So the priority for the factors that may differ from person to person. So actually these information, these factors what we are talking about, that exist in raster file, means it exists in different rasters. If you remember students, we have discussed the different types of spatial data, that is the raster data and the vector data. Actually the vector data that exists in data that in point, line and polygon, that is we can say, and if we talk about the raster data, that is we can say simply that a representation of pixels, and each pixel it's having its own characteristic, or we can say own attribute. So actually this information of different factor generally exist in different rasters. If you see, maybe in terms of the dollars, if you are talking about the cost, maybe in terms of the dollars, maybe in terms of the distances, maybe in terms of the degrees and so on. For example, if we are talking about the distance, assessing distance to the different facilities and amenities, then here we are talking about the factor regarding the distance. If we are talking about the cost of the particular land, then we are talking about some rupees or dollars. If we are talking about the slope, then we are mainly concerned with the angles. So that is it is explained here. These information whatever we have talked about, that the overlay analysis need various factors. Actually these factors exist in raster format, maybe in terms of the dollars, distances, degrees and so on. You can give various examples also. Actually the land cost will be in dollars, distances may be in meters, kilometers, miles, and thus we can obtain a meaningful result. So actually the factors in our analysis may not be equally important. For example, the cost of land is more important in choosing the site in relation to the distances to the utility. So basically what is explained here, that what are the factors or what are the input layers we are taking, that weight is assigned according to its importance. Some factors are more important than the other factors. So if we see many times what I have said, we need many factors. So it means different rasters are needed because these informations exist in raster. So if even within a single raster, if we can even prioritize the values, if we are not prioritizing the layer, means different rasters or different factors, even in single raster, we can also prioritize the values. Some values in particular raster may be ideal for our purpose. For example, according to us, the ideal value for the slope is 0 to 5 degree, means we are prioritizing 0 to 5 degree in a single raster, while others may be other values may be good, or we can say may be bad or unacceptable. So actually in single raster also we can prioritize the value. Basically in different raster we can prioritize the different factors according to the importance, or even in the single raster also we can prioritize the values. So these are the things that is needed in the overlay analysis. That is the factors, various factors, and the information of various factors that exist in rasters, and those rasters are prioritized according to our importance, what we need, and its importance will differ from person to person, and even in the single raster we can prioritize the values. So these are the things that are generally needed in overlay analysis. Let us talk about what are the steps to perform overlay analysis before coming to the example. What are the certain steps? Before starting any work for the overlay analysis, it should be very much clear what problem is to be addressed. What is the first problem is to be addressed? For example, in previous slide we have said, that is we have to select a suitable site for new housing development, means a new suitable site for new housing development. This is to be addressed, means first we have to define the problem, or we can say we have to construct a road in order to reduce the traffic jams at particular points, means this problem is to be addressed. So first step to perform the overlay analysis is to define the problem, means simply what problem is to be addressed. Then we can break the problems into sub-models, means we are talking about here traffic jam is one of the thing we can say. Then finding out the alternate route is another thing we can say. So we can take bit by bit. Another step that is to be followed after this is determining the significant layers. Means what are the factors, what are the requirement we can say for this, what are the requirement, what are the factors is to be considered in order to address this particular problem. So we means we have to select different layers, maybe in terms of the cost of the land, maybe in terms of the distance, that is accessibility to certain utility, etc. Determining the significant layers which is to be considered. Then reclassifying or transform data within a layer, means there are different layers we have to reclassify or even we have to transform the data within a layer. Because if you remember, I have said those factors actually these information for which is to be considered that exist in raster. So reclassifying and transformation of the data within a layer is to be done. Then weight to the input layers are assigned, which is more important and which is we can say less than that, and which is the least important. According to the priority, we can give the weight to the different factors. Then add or combine layers. We have to add, we have to integrate all the layers. In previous slide you have seen how we have taken different layers. So we have to combine different layers in order to get the best location for new housing development. So once we get the best location, then we can analyze various things, various aspects, and accordingly we can plan. So these are the some simple steps which is to be followed for overlay analysis. That is, first we have to define a problem which is to be addressed. We have to break that problems into submodels. Then we need what are the factors that is to be considered in terms of the input layer. Then we have to reclassify and transform the data. Then we have to assign particular weight to the input layers according to the priority, and then we have to integrate all these layers in order to get the best suitable location, and finally analysis is to be done. So here I would like to discuss about the few available tools, particularly in a software that is ArcGIS, because it is most commonly used among the students and even by the professionals also. So these are the available tools in ArcGIS, and brief discussion of these tools you can see here. First tool that is given here is fuzzy membership. Means here what we do, we transform the input raster, because what I have said, the information is given, whatever the multiple layers we are considering, the information is given in raster. So we have to transform the input raster into 0 to 1. In this, all the raster is transformed into 0 to 1 scale, indicating the strength of the membership in a set. What is the strength? Means which is the most important and which is the, we can say, intermediately important, or which is the least important. Then based on a specified fuzzification and algorithm, these functions actually this software holds. So first tool is fuzzy membership, another tool is fuzzy overlay. Fuzzy overlay simply combine fuzzy membership rasters, whatever the input layers of data we are having, we are going to combine the fuzzy membership raster data together based on certain overlay type, because there are different overlay type according to the data, according to the best requirement which suits the data. Accordingly we can choose the overlay type. So simply in fuzzy overlay what we do, we combine the fuzzy membership raster data together and based on the selected overlay type. Then locate regions. There is another tool what we do, we locate regions, that is identifying the best location, best site, that is what known as locate region here, or groups of contiguous cells from an input utility raster that satisfy the specified evaluation criteria and meet identified shape, size, number, then inter-region distance construct. Actually, overall we can say identifying or locating the region which meets our set criteria. Whatever criteria we have set, whatever problem is to be need. So accordingly we can say identified the best location, that is the that can be performed through the locate regions. Then coming to the weighted overlays several rasters using a common measurement scale. Simply here we are talking about that weighted overlay analysis. Here what we do, we overlay several rasters because all the information are in raster. So we overlay several raster using common measurement scale and weight, each according to its importance. Simply that is weight is given according to the importance. Then coming to the weighted sum, overlays several raster. Again here we are overlaying several raster, then multiplying each by their given weight and summing them together. So these are few of the tools with their description what we have discussed. Now, how overlay analysis model works? Suppose this is our real world. This is our real world. Now, according to the problem that is to be addressed, certain factors are needed to be considered in terms of the input layer. So, actual our data is one of the, we can say, one of the layer. Then another layer or factor we can choose, that is the survey control. We may have the water feature input layer, we may have the boundaries, then we may have the certain addresses, then we may have the transportation, then we may have the elevation, then imagery, then data slides. So these we can say overall, this is all we can say different layers. Mainly this overlay analysis is performed in GIS environment in which the different factors are considered in terms of the different input layers. So basically on this model that we input different factors in terms of the layers, in terms of the raster information, because these layers, or we can say this information in terms of the raster, of which reclassifying and transformation is to be performed. So accordingly we can go for the overlay analysis. So coming to the few of the case studies, some of the parameters here we can say that some parameters have been used to determine the best dumping site. We have to choose, we have to locate region, ideal region for the best dumping site. Here you can say land use, land cover. If you see, one of the factor is land use, land cover is to be considered, built up is to be considered, elevation, then road and water body. These are the factors or input layers that is to be considered for this overlay. Then we can integrate all this layer, we can combine all this layer in order to get suitable information on the basis of set criteria. So overall you can see all these layers have been overlaid and combined together. Actually this input layer is the factors which we have considered. According to another case study, here I have coined case study of Kolkata Municipal Corporation KMC, factors used to assess the urban green space vulnerability. Which places are more vulnerable, where the green spaces are lacking according to the per unit area, according to the we can say per person. So various factors is to be considered. If you see student, here I have considered the factors like that we are taking the different layers, and these factors are the input layers actually. So the factors which are considered here, if you see on the screen, proximity to the settlement, proximity to the roads, proximity to the railways, land use, land cover, NDVI. Then this is, we can say, land surface temperature, proximity to stream, VCI, elevation, proximity slope, etc. All these factors you can see here, we have considered so many factors. So these are the factors which are overlaid and combined together in order to get the vulnerability assessment according to the set criteria. So here Finally, we have got the urban green space vulnerability map. So, showing the red color is showing these areas are more vulnerable. We can say very highly vulnerable. Rest of the areas, these are, if we are talking about these areas, this is the highly vulnerable area, and green color areas, we can see these are the moderately or low vulnerable. So this is giving, at a glance we are getting various information from this. So how to set weight for each parameter based on their influence. Suppose we are taking another study. If you see here, we are going to map out environmentally vulnerable neighborhoods. Which are the environmentally vulnerable neighborhoods, in which we have taken certain factors, or we can call it decision criteria, maybe in terms of irregular supply of water, maybe in terms of open drain, improper cleaning. Accordingly, we can say during the survey, according to the importance, if we are talking about the irregular supply of water, open drain, improper cleaning of the drains, then the respondents will answer according to them which is more important. So, which is more important, that can be assigned higher weight as compared to the other. So, weights are here ranked according to the importance. So, accordingly we have given the weight to the inadequate waste collection, water accumulation, overcrowding, narrow streets, substandard housing, neighborhood disaster, or water quality index, air pollution, noise pollution. So, for all this sub criteria, we can say this is a decision criteria. In that we have taken several sub criteria. For all this we have assigned weight according to their importance. Now, after assigning weight according to their importance, we are going to combine all these factors, all this input layer, to get the environmentally vulnerable neighborhoods. So, finally, we have got this is environmentally vulnerable hood. Students, at a glance, if you see this map at a glance, you will get various information. For example, this the red color neighborhood are the most vulnerable, yellow is moderately vulnerable, and green is least vulnerable, we can say. So, another case study I would like to hear, similar, only just we can say here different decision criteria have been taken, have been considered. If you see in terms of the percentage of low income household, we can say respondents educated below graduation, or you can say percentage of respondents engaged in organized activities, or kacha mixed type of houses they are having without. So, overall, basically explaining this is not something like that you have to do this type of work. This is just to make you understand that this several factors which we are considering, that has to be assigned weight according to the importance. So, basically you can take here also we have taken this, you can see the different input layers, and then we have combined together in order to get socio-economically vulnerable neighborhoods. So, there we have taken environmentally vulnerable neighborhoods on the basis of different factors. So, on the basis of here also again some decision criteria, that is different factors, we have found the socio-economically vulnerable neighborhoods. If you see another case study, this is the last one. Here we have done ecological vulnerability of Wooler, Hokersar and Achar Lake using the following parameters. So, actually these are the water bodies, Wooler, Hokersar and Achar. These are the water bodies of Kashmir. So, in order to assess their ecological vulnerability, we have considered certain factors. Those factors are biological richness. This one is, you can say, biological richness, then disturbances index, this one is disturbances index, then forest fragmentation, this one is forest fragmentation, we can say, then vegetation type, you can take the vegetation type, then NDSI, LULC, NDVI, NDSI, LULC, NDVI, that is the normalized difference vegetation index, then we can take SAVI, then we can take rainfall, Here you can see what I have discussed in previous lecture, that is interpolation. So here you can see the use of interpolation, that is in rainfall data, in order to give the continuous representation. So then we can have the temperature, then we can have the slope, then we can have the MNDWI, then we can have the NDMI. So these are the several factors which is to be considered in order to map out the ecological vulnerability of these water bodies. So these water bodies are actually, this is Wooler, this is Hokersar, and this is the Achar. So these are the water bodies, and we can say here we have mapped out the ecologically vulnerability map. So you can, here you can find which are the particular regions which is to be prioritized, which are the more vulnerable, where the planning is needed in order to reduce this vulnerability. For lots of information we can attain through combining these layers. So basically overlay analysis can simply be defined as overlay analysis in use of overlay in spatial analysis can simply be defined as combining different data set, integrating different data set on the basis of certain common scales, and these different layers are data set are actually the factors, and the information is given in raster. Basically it is present in raster which needs reclassifying transformation. So all these layers, all these factors are combined in order to meet the set criteria, in order to address the particular problem through which can give some new information, or we can say some useful information that what actually needed. So that's all for today's lecture. Have a good time, students. Thank you.